Imagine you reach into a tank, and something reaches back. 8 arms wrap around your hand, tasting you, reading you, deciding what you are. No backbone, no skeleton, no social group, no parental guidance. It lasts for barely a year, and yet, it is one of the most intelligent beings on the planet. In many ways, the octopus is as close to alien life as we may ever see. They live in every ocean in the world, in the deep sea, in kelp forests, in coral reefs, along rocky shorelines. But none of that is what makes them unsettling. What makes them unsettling is this. Most of their 500 million neurons are not in their brain, but in their arms, which can smell and taste and even think. Their cognitive ability matches that of many large-brained vertebrates. They have left scientists stunned about how a creature so far from us on the evolutionary tree could evolve such complex behaviors, their intelligence emerging in an entirely novel and independent way from our own. The last common ancestor we shared with the octopus lived between 518 and 750 million years ago, back when Earth was just a giant snowball, before plants even existed. That ancestor was a simple worm with barely any nervous system at all. Evolution invented intelligent life not once, but twice, in 2 completely different ways, and the octopus is the strangest proof of that split. Cephalopods evolved over 500 million years ago, long before any fish, reptiles, or mammals appeared on Earth. Around 140 million years ago, the lineage that produced the octopus lost their shells, making them nimble and agile, but vulnerable. Because an octopus has almost no hard parts except its beak, it can squeeze through any hole as long as it is larger than its eyeball. Survival of these soft-bodied creatures for so many millions of years seemed unlikely in a sea full of dangerous, hungry predators. But this vulnerability may be precisely what has allowed the octopus to become this remarkable creature we know today. The first survival tool they developed is one of the most sophisticated systems in nature. In the blink of an eye, an octopus can almost completely blend in with its surroundings. Chromatophores are organs speckled across their skin like freckles, tiny pigment-filled sacs surrounded by radial muscles that stretch to reveal color. Beneath that sits a layer of erotophores, producing metallic blues and greens. And using structures called papillae, the octopus can change the texture of its skin, creating ridges and bumps that rise and fall in 3 dimensions. One researcher observed an octopus changing its camouflage 177 times in 1 hour, reaction times reaching up to 200 milliseconds, as fast as the fastest blink you can do. But it gets stranger. Despite doing so much with color, the octopus is thought to be colorblind. It only has one type of photoreceptor in its eyes, and yet it matches the color of its environment perfectly. This is the colorblind paradox. Researchers found that the skin itself is sensitive to light due to the photoreceptor genes active within it. Even when skin was detached from the body, it could respond to light and change its chromatophores. Scientists realized that an octopus can see with not just its eyes, but also its skin, detecting color directly without neural processing through the brain at all. Then things get even weirder. To understand the octopus, you have to stop thinking of it as a single animal. With approximately 500 million neurons, its nervous system is comparable to that of some mammals. But only about 10% of those neurons are in the central brain. Everything else is in the arms. Each arm contains its own cluster of neurons that can process information, sense the environment, and make decisions without checking with the head. It's like having 8 separate living beings attached to your body. The central brain might give a general command, move towards that rock, but it doesn't micromanage how the arms get there. The arms figure out the terrain, decide which suckers to use, and handle the mechanics all on their own. They think, they taste, they react. Researchers proved this with the autonomous arm experiment. A severed arm doesn't just go limp. It remains alive, reacts to stimuli, tries to catch food, and tries to pass the food back towards the place where the mouth used to be. There is real intelligence going on in the arm itself. But if the arms are all independent, how do you stop them from eating each other? The solution is built into the skin. Octopus skin produces a chemical that acts as a shutdown signal for the suckers. When an arm brushes against another part of the same body, the suckers sense that chemical and refuse to grip. Without the signal, the suckers treat the limb like any other piece of meat. The intelligence of an octopus isn't just thinking in the way we understand it. It has parts of its body that deal with things entirely on their own. And on top of all of this, they are genuinely smart. Octopuses learn to open screw cap jars, navigate multi-step puzzles, and recognize individual human caretakers, responding positively to some and negatively to others based on prior interactions. Consider the coconut-carrying octopus, which transports shell halves across the ocean floor to assemble into a portable shelter for future use. The octopus has to imagine the future and connect the dots between past events, current actions, and future events. Some scientists argue this is a rare example of composite tool use, previously thought to exist only in humans, some primates, and some birds. Octopuses have also been filmed bouncing pill bottles like toys, escaping tanks to hunt in neighboring aquariums before returning home by morning, and shooting jets of water at lights to turn them off. One in New Zealand became so notorious for breaking out to eat sharks that the aquarium had to install motion sensors. All of this intelligence evolved without society. Dolphins, elephants, crows, primates, they all live in complex groups. Octopuses are loners. The social intelligence hypothesis, the idea that intelligence evolved from group living, cannot explain the octopus. Perhaps the pressures of finding food and evading predation are enough. When the environment is sufficiently complex, intelligence emerges even in the absence of social pressure. And yet, nature gave this intelligence a hard time limit. Most octopus species live for around 2 years. An octopus can recognize faces, solve mazes, and plan for the future, and then dies before it can pass any of that down. Every octopus starts from zero. There is no culture, no parents, no one to teach the young how to hunt or where to hide. And their death is engineered. Once a female lays her eggs, the optic gland shifts from regulatory organ to death gland. She stops eating. Her tissues waste away. She guards her eggs until she dies right as they hatch. Researchers surgically removed the optic gland from mother octopuses after they have laid their eggs, and the results were immediate. The octopuses didn't die. They started eating again and lived for months longer than they should have. Nature built one of the most sophisticated nervous systems on Earth and then installed a self-destruct button. The octopus gave us a rare chance to investigate an alternate intelligence, an alien-like life form here on Earth. We once thought there was only one model for intelligence. We now know there are at least two. Arms that think for themselves, skin that sees, a body that knows its own chemistry, a mind distributed across 9 brains at once. Nothing about them is normal. Nothing at all.